So for question 3, we have this question. So at the instant shown, the length of the boom is decreased at a constant rate of 150 mm per second, where the boom is being lowered at a constant rate of 0.05 radians per second. Knowing that theta is 30 degrees, determine the velocity of B and the acceleration of point B as well. So with these two information, we know that VB with respect to the frame is decreasing at 150 mm per second in the 30-degree direction. Okay, so this point B is moving down relative to this frame. The frame is attached to this rod. Can you see this half rod over here? So you'll rotate and translate alongside with this rod. So we only measure linear movement, so there'll be negative 150 in the 30-degree direction. Okay. Next, you know that the angular velocity has to be negative as well, because for the boom to lower down, it has to rotate at the clockwise direction. As you all know, our convention is clockwise will be in negative. Alright. So to find velocity of B, we can express it as the velocity of B in the reference frame plus the velocity of the entrant velocity, which is the B prime, okay, the imaginary point B prime. So we have VB from frame, we got omega, and then we know the distance of B prime to the absolute frame. So we know VB equals to VB from F, so this bring it down over here. VB prime is just omega crossed with the position vector, and this is what we get. Very simply, we can find out that the velocity vector is this. So velocity of B is 0.474 in a negative 78.435 degree direction. Okay. Next, in the question, we know that it has both constant rates. So basically, there's a constant rate of the velocity of B with respect to the frame. So constant rate, and the boom being decreased at a constant rate as well. What we know from constant rate is constant rate means that there will be zero acceleration. So there will be zero linear acceleration and zero tangential acceleration. Okay. So acceleration can be broken down into just look at this over here. Acceleration of B can be broken down into acceleration of B with respect to the frame, acceleration of B prime plus the Coriolis acceleration. So let me separate out all of this. I know that linear acceleration is 0 because it's decreasing at a constant rate. Okay, so B with respect to the frame, the acceleration will be equals to 0. So we don't need to care about this. We need to care about acceleration of B prime. Okay. So acceleration of B prime, what is it? So let me remove. So just look at this diagram over here. It's very hard to see. So just imagine B prime is just a point that's glued onto the point B. It cannot go up and down, but it can rotate. So for example, let me arrange this. So I'll bring forward by 1. So just imagine there is this point, okay? So you don't care about this velocity vector, don't care, just care about this point. So this point, this imaginary point is glued such that it cannot move linearly, and yet it can rotate. So you can only measure rotational motion. So if we know that you can only rotate in the circular motion, knowing that this is a fixed length already, right? This means that in the circular motion, there's only centripetal acceleration and tangential acceleration. Hold on. And because we know that its angular velocity is constant rate, so there will be 0 tangential acceleration, and hence it will only have centripetal acceleration because it's moving in a circle. Hence, my acceleration of B prime is only the centripetal acceleration. Okay. And next, we have the Coriolis acceleration. So this Coriolis acceleration, right, is this point B, the Coriolis acceleration at point B. So again, I will send this back. So wait, sorry. Bring this out forward by 1. So imagine you are doing chapter 1, the kinematics of a particle. So you just care about this particle, this imaginary particle is moving linearly and at the same time it's rotating. So this is a curvilinear motion. Hence, there is Coriolis acceleration. Yep. So what is omega and what is velocity? It's all given to you because send to the back. You are given the linear velocity and angular velocity. So very simply, you can find out the Coriolis acceleration. So just put it in. Okay. So omega cross velocity vector is 120 degrees. Alright. So very simply you can find out what's the acceleration of B, and the acceleration of B will be 0.04056 in a 176.31 degrees direction. Alright, so that's the answer for acceleration of B. And that's the answer for question 3.